Welcome back to another video on infinite pi. Today, we're going to talk about the second part of our introduction to probability, which is on definitions. So there are some key definitions that we want to understand before we kind of get into our more detailed discussions of probability. So today we're going to kind of discuss some key definitions, and then we'll give us a very simple definition of probability. So first, building off of what we discussed in our previous video about sets. We want to define a new term called the sample space. Now, we talked previously about an experiment where there are, a number of possible outcomes of this experiment. And in this case, our experiment has 9 possible outcomes that we'll call pebbles. So there's 9 pebbles here in this image, and we'll count them as outcomes. Now, the sample space S of an experiment can be defined as the set of all possible outcomes of the experiment. So as we talked about in our previous video, the definition of a set is, a variety of things represented by one thing. And in this case, the set is S, one thing, but it represents all the possible outcomes of the experiment. So in this image, the sample space S is this whole box here, right? The whole box here. All 9 possible outcomes. Now, the second term we want to define is event. Okay? And we'll assign the event to A or B. Okay? And what that means is that event A is a subset of the sample space S. Now, what does a subset mean? It's still another set, but it is a set contained within another set. That's how you can think about it. A set contained within another set. And in this case, the event A is contained within the sample space S, and so is the event B. So as you can see here, the whole sample space S is this entire box, but A is contained within that. That is what we call an event. And B is right here. Now, our third and final definition here is the word occurred. And instead of giving you a proper definition of the word occurred, I want to use it in a sentence. So we say that the event A occurred if the actual outcome is in A. Now, as we talked about in our previous video, we are conducting an experiment, and the experiment is performed, and it is unknown which outcome it will be, but at the end, it crystallizes to an actual outcome. And we're using that previous assumption here to show that there is going to be an actual outcome. And if that actual outcome is within, event A, then event A is said to have occurred. If the actual outcome is not in A, let's say this pebble is the outcome, the event A has not occurred. So once again, if the pebble chosen is the actual outcome and it's within the definition of the event A, then event A has occurred. But if it hasn't, if the pebble that is the actual outcome is not an A, then the event has not occurred. So now that we have these 3 definitions, we are able to move on to our simple definition of probability. Now, our simple definition of probability reads, let A be an event for an experiment with a finite sample space S. The probability of A is P of A equals the number of outcomes favorable to A and the total over the total number of outcomes of S. Now, once again, we can try to change this word favorable to mean if the number of outcomes that are within A or within the event A. And so we can count here that there are 5 events within A, and the total number of outcomes of S is the number of pebbles within this box, like we just discussed before. and that is 9. So the probability of A here is 5 over 9. 5 over 9. Now, why is that? The number of outcomes favorable to A is if this event occurred, if this outcome was the actual outcome, then event A would have occurred. And there are 5 possible outcomes within A that would make event A to have occurred. And obviously the number of total outcomes of S is the number of pebbles within this box, like we talked about before. That's 5 over 9. We can use a similar logic for probability of B. There are 4 pebbles within B. 4 over 9. The probability of A union B, or A or B, like we talked about in the last video, is 1, 2, 3, 4, 5, 6, 7, 8 pebbles. 8 over 9. Disjoint, we talked about, is the word and. So 1 over 9. Talked about A, this is A complement, what's not an A. So 1, 2, 3, 4, not an A. And similarly, there are 5 that are not in B. So we can use this very simple definition of probability under these circumstances. When there's a finite sample space S. And in this case, there's a sample space that is finite. There's 9 possible outcomes, and that's a finite number. So really, you're able to use this definition of probability.